Hello student, in previous lecture we have seen a basic concept related to congruence relation. Now in today's lecture we are going to start Fermat's theorem. Fermat theorem and also application of Fermat theorem. So if P is a given prime, if P is a prime number and P does not divide A, P does not divide A, then Fermat theorem says that A raised to P minus 1 congruence to 1 mod P. Okay, so this is the statement of Fermat theorem. All of you know that already we have seen the definition of prime number, already we know the definition of divide. So if P is any given prime number and if P does not divide A, then what Fermat theorem says, A raised to P minus 1 congruence to 1 mod P. Now what is an application of Fermat theorem? We use this Fermat theorem to determine remainder of large power. For example, suppose you want to determine find the remainder of 2 raised to 105 when divided by 11. So now it is not possible to take 2 raised to 105. Still we are going to determine what will be the remainder when 2 raised to 105 is divided by 11. Even though your computer will not able to determine what will be the exact number of 2 raised to 105. Okay, so what Fermat theorem says here, since we are dividing this number, we are going to divide this number by 11 and all of you know that 11 is a prime number. So P is what? 11 and A is what? 2. What is A? Since raised to power, so this is what? 2 raised to. So what is our A? 2. And all of you know that 11 does not divide 2. Already 2 is a smaller number than 11. So 11 does not divide 2. So what Fermat theorem says, A raised to P minus 1, that is 2 raised to 11 minus 1 congruence to 1 mod P. 1 mod 11. Okay, what is meaning? What this implies? This implies 2 raised to 10 congruence to 1 mod 11. So if we divide 2 raised to 10 by 11, then what will be the remainder? Remainder is 1. But we want to determine 2 raised to 105. आता पण आपण फाइंड केलाय 2 raised to 10. आपल्याला कुठपर्यंत जायचंय? 2 raised to 105. सो आपण जर इथे 2 raised to 10 चा 10 पॉवर जर घेतला आपण, then बघा आपल्याला काय मिळते बघा, 1 raised to 10 mod 11. इथे आपण कोणती प्रॉपर्टी अप्लाई केली आहे? A congruence to B modulo n, C congruence to D modulo n, then AC congruence to BD modulo. सो आपण इथे त्याचा पॉवर घेतलाय. सो इकडे पण पॉवर घेतलाय. सो 2 raised to 10 A raised to m raised to n. So A raised to mn 2 raised to 100 congruence to 1 mod 11. सो आता पण आपण आलोय 2 raised to 100 ला. आपल्याला माहिती आहे की 2 raised to 100 हा जो काही नंबर असेल त्या नंबरला जर मी 11 ने डिवाइड केलं तर रिमेंडर माझा काय असणार आहे? 1. मला कुठपर्यंत जायचंय? 2 raised to 105. So say this is equation number 1. Now what is 2 raised to 5? 2 raised to 5 is equal to 32 and which is congruence to what mod 11? It is congruence to 10 mod 11. If we divide 11 by 32, then it is equal to 10 modulo 11. So say this is equation number 2. Say this is equation number 2. So hope you understand why I am taking here. इथे मी का पॉवर घेतला असेल बट 2 raised to 5 कारण की आपल्याला 2 raised to 105 पर्यंत जायचे. ऑलरेडी आपण 2 raised to 100 रिमाइंडर फाइंड केलाय. आता आपल्याला 2 raised to 5, but 2 raised to 5 is what 32. ओके, and 32 ला जर आपण 11 ने डिवाइड केलं तर रिमाइंडर इज व्हॉट 10. सो या दोन इक्वेशनला जर तुम्ही मल्टिप्लाय केलं, मल्टिप्लाय 1 and 2, multiply 1 and 2, we get 2 raised to 100 and 2 raised to 5 congruent to 1 into 1 mod 11. Sorry, 1 into 10 mod 11. इथे रिमाइंडर 1 है, इथे 10 है. So it is what 2 raised to 105 is congruent to 10 mod 11. So if we divide this number by 11, what will be the remainder is 10. Next example. Find the remainder when 6 raised to 356 is divided by 7. Divided by 7. So now here you cannot determine this number. It is not possible to determine, even though calculator is not able to determine this number, or your computer is not able to determine what will be the exact digit of this number, but still we are going to find what will be the remainder of this number when we divide it by 7. Why it is possible? Because since we are dividing by prime number, आपण ही आणि आपण फॉर्मॅट थेरम आपण अप्लाय करू शकतो बघा. कारण की आपण या नंबरला कुठल्या कंपोजिट नंबरने डिवाइड नाही करत आहे, म्हणजे 2 4 6 अशा नंबरने डिवाइड नाही करत, आपण एका प्राइम नंबरने डिवाइड करतो. सो व्हाट इज p here? p is what 7, a is equal to what 6, आणि आपल्याला माहिती आहे की 7 does not divide 6. 7 हा काय 6 ला डिवाइड करत नाही. मग बाय युजिंग फॉर्मॅट थेरम a raised to p minus 1 congruent to 1 mod p, म्हणजे 6 raised to p minus 1, 6 congruent to 1 mod 7. आता मला हे माहित झाले की 6 raised to 6 congruent to 1 mod 7, पण मला कुठपर्यंत जायचंय 357 ला. मग मी 357 च्या जवळ जाऊ शकतो का? मला 6 चा कोणता पॉवर घ्यावा लागेल तेव्हा मी 357 च्या जवळ जाईल. तर काय करा, 357 ला 6 ने डिवाइड करा. ओके, ह्या 6 चा मला कितवा पॉवर घ्यावा लागेल की जेणेकरून मी 357 च्या जवळ जाईल. सो then 757 remainder is what 3. So या 6 चा मी जर 59 पॉवर जर घेतला, 59 पॉवर, so if you take 6 raised to 6 raised to 59 is equal congruent to 1 raised to 59 mod 7. So what is 6 raised to 6 59? If you multiply 59 by 6, you will get 6 raised to 3 54 congruent to 1 mod 7. म्हणजे आपण आता कुठपर्यंत आलो आहोत? सिक्स इक्वेशन नंबर 1. आपल्याला जायचे 3 raised to 57. आता पण आपण आलो 3 raised to 6 raised to 354. म्हणजे अजून आपल्याला किती पॉवर कमी आहेत आपल्याकडे? 3 powers are less. So what is 6 raised to 3? 6 raised to 3 is what? 6 raised to 3 is or you can do one thing, that 6 raised to 2 is what? 36. 36 and 36 congruent to 1 mod 7. आपल्याला माहिती आहे. So this is equation number 2. बघा 6 raised to 36 आणि त्याला जर 7 ने डिवाइड केलं तर रिमाइंडर किती येणार आहे 1. नाउ आणि 6 कॉम्प्रेन्स टू 6 mod 7. 6 इक्वेशन नंबर 3. आता बघा मी अजून एक 6 का घेतला कारण की आता 54 आणि 2 किती होतील 56. आपलं कुठपर्यंत जायचं 57 पर्यंत, त्यामुळे अजून एक मी 6 घेतला. आता मी जर 1 2 आणि 3 या तीन इक्वेशनचं जर मल्टिप्लिकेशन जर घेतलंय तर 54 प्लस 2 56 आणि हा 1 म्हणजे 57. मला काय मिळाले 6 रेज टू 357 कॉम्प्रेन्स टू 1 into 1 हा 1 1 आणि 6 यांचं मल्टिप्लिकेशन जर केलं तर mod 7. सो ह्या नंबरला जर मी 7 ने डिवाइड केलं तर माझा रिमाइंडर किती असणार आहे? आन्सर विल बी 6. नाउ लास्ट डेफिनेशन ऑफ दिस चॅप्टर इज युलर फाय फंक्शन. युलर फाय फंक्शन suppose n is given any given positive integer greater than 1. N is given any positive integer greater than 1, then Euler phi function of n is denoted by this symbol phi n. Phi n, and it is a collection of all positive integers which are less than n and relatively prime to n. Okay, so for example, if you want to determine what will be the phi of 6, so what is phi of 6? All positive integers, not all, sorry, number of positive integers, sorry, one correction here, number of positive integers. So how many integers which are relatively prime to 6? 1, then 2 not, 3 not, 4 not, 5. Okay, only 2 integers. So what is phi of 6? Phi of 6 is equal to what? 2. There is no need to write this 1 and 5. This is just only for your information. So what is phi of 6? Phi of 6 is equal to 2. What is phi of 8? All positive integers which are relatively prime to 8. So how many integers which are relatively prime to 8? 1, then 3, 4, 5, 6, 7. So there are 4 integers which are less than 8 and relatively prime. What is meant by relatively prime? Their GCD with 8 is equal to 1. तुम्ही या नंबरचा GCD घ्या बरोबर 8 बरोबर, it will be 1. So here 4. What is phi of 12? Phi of 12 1, then 5, 6 not 7, 8 not 9, 10, 11. So phi of 12 is also 4. So hope you understand. So here we have finished our second and third chapter. Complex relation also we have finished. Prime numbers also we have finished. Now in next lecture we are going to start a complex number.